Yes. We know the second order closed loop transfer function is equal to C of s by R of s is equal to omega n square divided by s square plus 2 zeta omega n s plus omega n square. For step input, R of s is equal to 1 by s. So, C of s is equal to omega n square divided by s into s square plus 2 zeta omega n s plus omega n square. So, to get the time response of the system, we have to take the inverse Laplace transform for this function. So, L inverse of C of s is equal to L inverse of omega n square divided by s into s square plus 2 zeta omega n s plus omega n square. So, it is not a standard form, we have to make it into the standard form. That is either L of 1 by s is equal to 1, L of 1 is equal to 1 by s, Laplace transform of cos a t is equal to s plus a, sorry, s divided by s square plus a square, L of sin a t is equal to a by s square plus a square e power minus a t sin omega t is equal to s plus a into s plus a the whole square plus b square e power minus a t cos b t, which is equal to b divided by s plus a the whole square plus b square. This is the standard form. We have to make this term into any one of this standard form. So, to obtain the standard form, we have to take the coefficient of s, that is 2 epsilon omega n, divide this term by 2 and square this term, add and subtract. So, this will be omega n square divided by s into s square plus 2 zeta omega n s plus omega n square plus omega n square minus epsilon square omega n square. So, it can be simplified as omega n square divided by s into s plus epsilon omega n square plus omega n square into 1 minus epsilon square. This term I can call it as damped frequency. So, it is omega n square divided by s into s plus epsilon omega n the whole square plus omega d square. Then we can split it into two factors like a by s plus b s plus c divided by s plus epsilon omega n the whole square plus omega d square. So, cross multiply and find the values of a, b, c, you will be getting a equal to 1, b equal to minus 1, c equal to minus 2 epsilon omega n. So, this equation will becomes 1 by s minus s plus 2 zeta omega n divided by s plus epsilon omega n the whole square plus omega d square. If you take the inverse Laplace transform for this function, L inverse of 1 by s minus L inverse of s plus 2 epsilon omega n divided by s plus epsilon omega n the whole square plus omega d square. This will be 1 minus s plus epsilon omega n divided by s plus epsilon omega n the whole square plus omega d square plus epsilon omega n divided by s plus zeta plus omega d square. You may compare these two terms s plus a divided by where a is epsilon omega n, b is omega d. So, it will be e power minus epsilon omega n t cos omega dt plus here we have b, it is omega d. So, omega d has to come. So, epsilon omega d divided by omega d into s plus epsilon omega n the whole square plus omega d square. So, 1 minus e power minus epsilon omega n t cos omega dt plus we know that omega d is equal to epsilon omega n into omega d divided by s plus epsilon omega n the whole square plus omega d square divided by omega n square root of 1 minus epsilon square. So, this omega n and omega n will get cancelled. So, this will be 1 minus e power minus epsilon omega n t cos omega dt plus epsilon divided by square root of 1 minus epsilon square into e power minus epsilon omega n t sin omega dt. So, take out this e power minus omega n t. So, 1 minus e power minus epsilon omega n t. So, cos omega dt plus epsilon divided by 1 minus epsilon square sin omega dt. So, take the LCM for this function. So, it will be 1 minus e power minus epsilon omega n t square root of 1 minus epsilon square cos omega dt plus epsilon sin omega dt divided by square root of 1 minus epsilon square. So, bring out this term outside this. So, it will be 1 minus e power minus epsilon omega n t divided by square root of 1 minus epsilon square root of 1 minus epsilon square cos omega dt plus epsilon sin omega dt. So, in the triangle made between epsilon and square root of 1 minus epsilon square, it will be sin phi is equal to square root of 1 minus epsilon square divided by 1. So, cos phi is equal to epsilon divided by 1. So, replace this value in terms of sin pi and cos pi. So, it will be 1 minus e power minus epsilon omega n t divided by square root of 1 minus epsilon square. Instead of square root of 1 minus epsilon square sin pi cos omega dt plus instead of epsilon cos pi sin omega dt. So, it will be 1 minus e power minus epsilon omega n t divided by square root of 1 minus epsilon square. This is a plus b formula, sin a cos b plus cos a sin b. So, sin a plus b omega dt plus pi. So, this is nothing but c of t, that is time response of second order underdamped system. If you draw the diagram, if you draw the various values of time t, then when you are applying the input, step input, unit step input, the magnitude will be 1. And for the various values of epsilon and omega n, then this value, the response of the second order underdamped system will be looking like this. So, from this expression, from the expression c of t is equal to 1 minus e power minus epsilon omega n t divided by square root of 1 minus epsilon square sin omega dt plus pi, we can draw this diagram. From this curve, we can able to determine all the time domain parameters of second order underdamped system, like overshoot and the time taken to reach the overshoot, that is called peak time, and the time taken to reach and settle with acceptable offset value, that is called settling time, and the time taken to reach the 90% of the maximum value, that is called rise time. All these parameters we can obtain from the equations for second order underdamped system. So, most of the system expressed this particular behavior. So, that is why I have chosen this topic to study the behavior of second order underdamped system. So, for an example, any voltmeter or ammeter which shows the output after getting the upper and lower vibration or overshoot and undershoot, that exhibits this particular characteristics. And suppose if the system has overdamped nature, then this overshoot and undershoot will not be appear. That response of overdamped system will behave like this. It will slowly moves to that settling value or final value without any overshoot and undershoot, it will be settled. The best example for overdamped system, this is for overdamped system. So, that is nothing but when the epsilon is greater than 1. So, the best example for this is the thermometer which is used by the physician. When the physician touch the patient's body, the mercury will be slowly expanded. It will take some time, but it will never goes overshoot or undershoot. That is the best example for overdamped system. Most of the physically available system will exhibit this overshoot and undershoot. So, that is why I have chosen this particular topic, that is the response of second order underdamped system response. Thank you. Thank you one and all.